Welcome back to our flipped classroom unit on balancing equations. I'm going to show you a couple tricks related to balancing equations. Sometimes it helps to know a couple hints and a couple tricks, and you'll kind of see this work out as you practice more examples. So if the balancing the equation isn't working for you, you want to, number one, check to make sure you wrote the formulas correctly. Excuse me. And sometimes you use the wrong charges, the wrong oxidation numbers. Sometimes you just write the formula incorrectly. So go back to the start and make sure you wrote the formula correctly. Check your atom inventory. So check on either side of the arrow. Make sure the left side of the arrow, your reactants, you counted them correctly. So maybe erase, go back to the beginning, erase your original count and do a recount. So check the left side and the right side of the arrow, the reactants and the products. And if you got that correctly, sometimes you need to do a little guess and check it. And you'll see a little bit of a guess and check example on our last example in this video. Let's take a look at the first one. So benzene, which is a carcinogen, can cause cancer. It's in cigarettes and other things. So reacts with oxygen to form carbon dioxide and water. So the first thing you need to do is write the reaction. And if you recall, the way we've been doing it is include a line out front indicating I can put any number I want out front. Can't change the formula. Reacts with oxygen. Remember, it's O2, it's diatomic, so O2. Two form, there's my arrow. Carbon dioxide, CO2, and water. Okay. Go ahead and do our atom inventory. I'll do this for Rick. So do our count. Left and right, products and reactants. We've got carbon, we've got hydrogen, we've got oxygen. On the left, we've got 6, and 2. On the right, carbon's 1, so it's definitely not balanced. 6 and 1 doesn't match. Hydrogen is 2. Oxygen's in 2 places, so that can be a potential error there. So make sure you realize it's 2 plus 1, there's 3 oxygens there. Okay. Our hints talk about, kind of the most important hint is if it's by itself, do it last. Oxygen's by itself, so do it last. You do that last either way because you do it in order, but that's fine. So 6 carbons on the left, we only have 1. Put anything we want here. We'll put a 6, that'll give us carbon, check. And again, one of the key things is to do a recount. People will add 6, or 6 times 2 is 12 oxygens here, but you have to do a recount every time. 6 times 2 is 12, plus 1 is 13. Super common error there. So make sure you realize anytime you put a number out front, it could affect more than one atom, more than one element, and you have to do a recount each time. Hydrogen, 6 and 2. So 6 and 2, put anything we want out front, so we'll put a 3. That'll fix my hydrogens. And again, do a recount. Don't just add 3 to this, so do a recount. 3 from here, 6 times 2 is 12, 3 and 12 is 15. Now sometimes this gets a little bit weird. Hopefully you're kind of thinking, well, what's up with that? We've got 2 here and 15 there. And we've got an even number and an odd number. What's going on there? So here's a little trick. So a little trick here is you can use coefficients, numbers out front, with halves. So you got to ask yourself, what can we put out front here to get 15 oxygens? And hopefully you realize you can go with 7.5. So 7.5 times 2 is 15. So that gets it balanced. That's the trick. But make sure you realize we can't have half of an O2. And remember, this is just a proportion. It's just a ratio. 1 to 7.5 to 6 to 3. So the proportion, the ratio is going to be the same if we double everything. So if you have to use a 0.5, double everything. So the actual final balanced reaction will be 2 C6H6s reacts with 15 O2s to form 12 CO2s and 6 H2Os. And if you're not confident in that, do a final check. 2 times 6 is 12 carbons. 12 carbons, yep. 2 times 6 is 12 hydrogens. 6 times 2 is 12 hydrogens, yep. And then oxygen, 15 times 2 is 30. 12 times 2 is 24, plus 6 is 30. So that proportion works. So if you're using the 0.5, so put a little note on here, so as you can 0.5, coefficients, and double. So if you need to, you can use 0.5 coefficients, but just make sure again you double them at the end. So, okay? So there's the first example. Here's the next one. Zinc and oxygen react to form zinc oxide. So zinc, let me be consistent with my colors here. So I'll do the reaction in blue. So zinc, it's not a diatomic, so it's just Zn, plus oxygen, that is diatomic, react to form. Now zinc oxide, Zn's a 2 plus, and O's a 2 minus, so ZnO. Now I'm not going to balance this one, it'd be pretty easy to balance, but what I do want to show you with this one is occasionally, you'll get coefficients like this. 4 zincs, yep. 2 times 2 is 4 oxygens and 4 oxygens. So occasionally you'll get coefficients numbers out front. The proportion is 4 to 2 to 4 or something along those lines. What you need to realize is if you can, you want to reduce coefficients. 4 to 2 to 4, I can reduce each of those by a factor of 2. So the final balanced reaction would be 2 to 1 to 2. So if you need to, or if you can, I should say, you want to reduce coefficients. So that's kind of the trick, or something to be aware of related to problems like that. Okay, so there's number 2. All right, here's number 3. So why don't you go ahead and pause the video, and we've been writing these reactions in class, so I'll give you a second here. Go ahead and pause the video, write out the reactions. So get the initial chemical formulas there so we can go ahead and take a look at balancing this. So a little practice on that. So go ahead and pause it and go ahead and work those out. Now that we're back, I'll go ahead and work through it. So with nickel 2 nitrate, I like to write the oxidation numbers, the charges right above the names. Remember nitrate, polyatomic aluminum, so that's just Al, we're not worried about that. You don't have to worry about the charge when it's by itself. The oxidation number is just Al. Aluminum nitrate, aluminum's in the middle, so you're going to go to your polyatomic sheet. We'll show aluminum in there, and then there's your nitrate. And nickel's by itself. So, running out the reaction, crisscross, remember this wants to give up 2 electrons, this wants to take 1, so you need a 2 to 1 ratio. Ni, parentheses, NO3, 2. Aluminum is by itself, it's not diatomic. When it's by itself, we don't worry about the charge, we're not worried about the oxidation number. 2, 4. Aluminum nitrate, AlNO3, 3. Remember, you're going to need your parentheses, and nickel. This is a certain type of reaction we're going to talk about here soon enough. So you'll see that here in the next couple of days. So, okay. All right, so go ahead and hopefully you've done your count already. If not, you can pause it and do your count. A little practice there. We've got nickel, nitrogen, split up the polyatomics, oxygen, and aluminum. Left, we've got 1 nickel, 2 nitrogens, 2 times 3 is 6 oxygens, and 1 aluminum. On the right, nickel, we've got 1. Nitrogen is 3, so we're obviously not balanced. And 3 times 3 is 9 oxygens, definitely not balanced. So, okay. There's 2 things on their own here, aluminum and nickel. So let's do those last. If we do those last, we won't affect any other elements. So let's start with the nitrogen. We've got 2 and 3. So that's kind of weird. You got an even number and an odd number. So if you go back to your math, 2 and 3, they have to match. So you're going to go to your least or your lowest common multiple. So the lowest common multiple of 2 and 3 is 6. So you're going to need to have 6 nitrogens on the left. Any number you want out front. So there's your 3. 2 times 3 is 6. And then we'll need 6 over here. We've got 3 in here. So we need 2 of those. So that'll give me 6. But this is where these get a little tricky. So the hint on here is go to lowest or least common multiple. So lowest or least common multiple, but you got to be careful because the 3 out front affects 2 other elements. The 2 out front affects 2 other elements. So you got to be really careful with your counts on these. So now we have 3 nickels, so you got to clean things up. Nitrogen we did, 2 times 3 is 6. Oxygen, 2 times 3 is 6. Times 3 is 18, so there's a lot of oxygen there. Be careful on that count. On the right, 2 aluminums, Nitrogen, 3 times 2 is 6. We did that already, so check. 3 times 3 is 9, times 2 is 18. So there you go. So big hint, hey, we're headed in the right direction. Now the beauty of finishing with the elements by themselves is I can put anything up front. So nickel, we've got 3 on the left, we need 3 on the right. Anything I want here, so there's my 3. Check. And then aluminum, 2 on the right. We need 2 on the left, so we'll put a 2 there. So check. And again, I like to do that final count. 3 nickels, yep. 2 times 3 is 6 nitrogens. 3 times 2 is 6 nitrogens, yep. 2 times 3 is 6, times 3 is 18. 3 times 3 is 9, times 2 is 18. 2 aluminums, 2 aluminums. So the hint there is least or lowest common multiple. So a little bit of, let's go back to a little bit of math. Okay. All right, so this one, excuse me, I gave you the formulas for this one already. And so go ahead and get started. You can do your count. Pause the video if you want. And do your count. This one you need to be kind of careful because you have hydrogen in 2 places and oxygen in 2 places. So be careful on your count. Zinc is 1. Oxygen 2 plus 4 is 6. So be careful there. Hydrogen 2 plus 3 is 5. And phosphorus is 1. On the right, zinc is 3, definitely not balanced. Oxygen, 2 times 4 is 8, plus 1 is 9. It's a little weird, you got 6 and 9. Hydrogen, we said 5, and 2 on the right. And then phosphorus is 2. So definitely not balanced, definitely not balanced. Going back to our hints, we've used this one maybe a little bit in class, not a ton. But nothing by itself. However, the big thing is you got water by itself. Or you got water. So the other hint was, if there's nothing by itself, no single elements, go ahead and do your water last. So we're going to do water last. So do zinc first, and then do phosphorus. So go ahead and try that. Pause the video. Go ahead and try that and see how it goes. Okay, now that we're back, we want to do the zincs first. So you got 3 zincs. We need 3 there. Check. But now you got to be real careful on your count here. 2 times 3 is 6 oxygens, plus 4 is 10. So part of the trick on this one is making sure you're thorough in your count. So 10 oxygens. Hydrogen, 2 times 3 is 6, plus 3 is 9. Be careful there. And skip the oxygen and hydrogen, do it last. So go ahead and jump ahead to the phosphorus. You got 1 and 2, so we'll go ahead and put a 2 here. That balances my phosphorus. And again, you got to redo a count. So don't just add 2 to the oxygen or the hydrogen. You got to totally recount. So again, oxygen 2 times 3 is 6. 2 times 4 is 8. So 6 and 8 is 14. And then hydrogen 2 times 3 is 6. 2 times 3 is 6. So you got 12. So part of this is again being thorough with your count. So in recounting those. So now hopefully we can put anything we want out front here and it won't affect any of the other elements. Hopefully that'll work. You can think of this from 2 perspectives. You can think of it from the oxygen perspective, but the thing that's a little weird here is oxygen's in 2 places. So you may want to think about it from the hydrogen perspective. So if we look at hydrogen, we got 12 and 2, 12 on the left, 2 on the right. So if we put a 6 there, hopefully that will clean things up. If you're thinking about it from oxygen, you have 8 oxygens already from here. So you need 6 more. So then you put a 6 there either way. So either perspective you put it there, but it's a little more involved if you think about it from the oxygen perspective. So that gives us 6 times 2 is 12 hydrogens. And then oxygen is 6. 6 plus the 8, I'm sorry, is 14. So do the final check. 3 zincs, yep. 2 times 3 is 6 oxygens. 2 times 4 is 8, so there's 14 total. 2 times 4 is 8, plus 6 is 14. And the hydrogen, 2 times 3 is 6. 2 times 3 is 6, so there's 12. And 6 times 2 is 12, so that's balanced. And then the phosphorus, 2 phosphorus, so that's balanced. So the hint here is do the oxygen, or do the H2O last. There's your big hint on that one. Okay? All right, on to the last one. So I gave you the formulas already. So go ahead and do your count. Carbon, oxygen, and iron. Carbon's 1. Oxygen is 4. It's 2 different places. Iron is 2. On the right, carbon's 1. Oxygen's 2. And iron is 1. Obviously not balanced. So, iron is by itself. Oops, come here. So, let's do the iron last. And it's in that order, so you do that last either way, but that's fine. So, let's start with the oxygen. Carbon's already balanced. Let's start with the oxygen. 4 and 2. So, I only have a line out front for one of these. So let me, just since I'm this far in the video, I'm just going to redo this. When I typed this up, I screwed this up. So my bad. So we'll get away from this. We'll go with this. Hopefully I won't screw people up too much. So, but I don't want to redo the video at this point. So 4 and 2 for the oxygen. So one thing you'd probably start thinking is, hey, let's put a 2 here. Let's put a 2 there. And that'll give me 2 times 2 is 4 oxygens. Then it'll change my carbon and it'll give me a 2 there. Like, okay, so I'm, look at my oxygens, I'm okay there. And then you think, hey, I got to put 2 carbons over here, so I'm going to have to put a 2 there. But then you think, that affects my oxygens. 2 times 2, or 2 is there, plus 3 is 5. Whoa. I'm starting to chase my tail. I'm going to change this one, and then I'm going to have to change this one. Change this one, and change this one. So if you start chasing your tail, you're probably on your wrong track, obviously. So you want to go back and maybe go through a little different thought process. Let's kind of work through the thought process on this one. So let me go back here. This may take a second. You want to erase and go back to original count. I'm just going back here on the screen. So there we go. So there's my original count. And so obviously 2 didn't work. So sometimes you got to do a little guessing and checking. So 2 didn't work in front of the CO2. So let's try a 3. So sometimes you just got to do a little guessing and checking. So 3 times 2 is 6 oxygens and 3 carbons. And that's just kind of the way it goes. Sometimes it's just not working for you. Go back and make sure you did your count right. We did. Formulas are right. We did. So now to clean that up, we would need a 3 in front of the CO because we have 3 there, and then 3 plus 3 is oxygen. 3 plus 3 is the 6 oxygens. So that's working for us. So sometimes you got to do a little bit of guessing and checking, and it's kind of the way it goes. And again, the beauty of finishing with iron by itself is I can put anything I want, put a 2 there, check. So there we go. 3 carbons, 3 carbons, 3 oxygens plus 3 is 6. 3 times 2 is 6. 2 irons, 2 irons. So there's your balanced equation. So again, that's a guess and check, and that was one that I was referring to earlier. Okay. Thanks for listening, and we'll follow this up in class.